Number 45 through 46, a rod of length L is rotated about its center with a moment of inertia of ml squared over 12. Number 45, what is the moment of inertia at a point L over 4 away from the center? So we have to use that parallel axis theorem. Which is the final moment of inertia equals the moment of inertia at the center of mass plus the mass times the distance we are away from the center of mass squared. So let's solve 45. The final moment of inertia equals, they gave us the center of mass moment of inertia, but I'm going to rewrite it as 1/12 ml squared. And instead of L over 4 away, I'm going to have 1/4. Now let's do that a different way. Let's do it M times 1/4 L squared. So this will give us 1/12 ml squared plus 1/4 squared is going to be 1/16 ml squared. So now we have to get a common denominator between 12 and 16, which would be 48. So it's going to be 4/48 ml squared plus 3/48 ml squared, which will be 7/48 ml squared. C. Number 46, what is the moment of inertia at either end of the rod? Either end. So, final moment of inertia equals the moment of inertia about the center of mass. Now, either end of the rod, so the rod is a length L, and the center of mass is L over 4. All right, so for at either end of the rod, so let's see, let's rotate it here. So if we know the total length is L and we're rotating here, that distance away from the center is going to be 1/2 that distance, which is L over 2. So we can say we can say M times 1/2 L squared. So that's going to be 1/2 squared is 1/4. We could take that out of the brackets. 1/4 ml squared. Get a common denominator of 12. Multiply the 1/4 by 3 over 3. So it looks like 4/12, which would reduce to 1/3 ml squared.